All right, you are welcome again. I trust you are doing well. Okay, today let's talk about partial derivatives. Okay, we're going to take a look at a particular problem and see through to it. On one of our previous videos, or lessons, we have talked about the basic of partial derivative, what partial derivative is all about, and simple examples. Okay, we have treated some examples. Now let's take a look at this problem. This question says, given that z is equal to sine inverse of x all over y, then we are to show that the first and second partial derivative of this z with respect to x, with respect to y, is equal to the first and second partial derivative of this z with respect to y and with respect to x. So this is what we are asked to solve. Okay, now pay attention please. We are going to take this lesson step by step so that you are going to understand every step. At any spot, you should be able to know what to do next. Okay, this video may be long. Why? Because I'm trying to explain in details. Okay, now let's go. First of all, we are going to find the first partial derivative with respect to x. Then we find the second partial derivative with respect to y. And then come back again, find the first partial derivative with respect to y, and then the second with respect to x. And then we find the final answers, the second partial derivative with respect to x, with respect to y, and with respect to y, and with respect to x. Then we compare both of them if they are the same, and they are likely to be. Okay, they are the same thing. So that is what we are asked to show. Now please pay attention. Let's start. First, let's start with the first partial derivative with respect to x. Okay, now we have our function z is equal to sine inverse of x all over y. Okay, now for us to differentiate this guy with respect to x partially, we are going to use substitution method. So substitution method, we are going to, in this sine inverse, inside the bracket we have x all over y. Let's call this x all over y a letter. So we say let u equal to x all over y. Okay, now as we call it a letter, that means our z is now a function of u. That means we are going to have sine inverse of u. Now, but before then, this place that we say let u equal to x all over y, let's differentiate this u partially with respect to x. So differentiating this guy partially with respect to x, we are going to have the partial u partial x is equal to 1 all over y. Partial u partial x is equal to 1 all over y. Is it correct? Yes. Now let's go. Here we say that z is equal to sine inverse of x all over y, and we declare the variable u to be x all over y. So that means here we have sine inverse of u, no longer x all over y, because we are substituting. True? Yes. So here, look at it. From the beginning, we see that z is a function of x and y. We substituted now. Z is now a function of u. So we are going to differentiate this z with respect to u, no longer with respect to x. But bear in mind that the aim or the goal is to find the partial z all over partial x. Now we are using substitution method. So here that we have z is equal to sine inverse of u. Differentiating this guy partially with respect to u, we are going to have partial z all over partial u is equal to 1 all over square root of 1 minus u squared. So this is elementary basic function. Okay, elementary basic function. And I think in one of our lessons we have talked about this, how we got this, the derivative of sine inverse of u, how it gave us 1 all over square root of 1 minus u squared. So because of our time, we have a lot of things to do, so I will not treat this again because we already done that on a separate video. So you can look for that and get it, okay, how it is like this. Now let's go. Now you know that we just apply substitution method, okay? So substitution method here, so that is to say we are going to bring the two derivative that we have, okay, the two derivative that we have. Now bringing these two, that means the method we apply is chain rule. Is what is chain rule. So bringing this, we see that the partial z all over partial x that we are looking for is the product of these two derivatives that we have. That is the partial z all over partial u multiplied by the partial u all over partial x will give us partial z partial x. Are we together? Now let's go. So bringing this together, we have solved and we obtained partial z all over partial u, and also we have obtained the partial u all over partial x. Bringing it together, we have that the partial z all over partial x is equal to 1 all over square root of 1 minus u squared multiplied by 1 all over y. Okay, but you remember that u is equal to x all over y. So substituting and combining these together, we're going to see that the partial z all over partial x is equal to 1 all over y square root of 1 minus, in place of u we have x all over y, but because u is squared, we have x all over y in bracket squared. Now let's open the bracket. Now we are going to have that the partial z all over partial x is equal to 1 all over y open bracket square root of 1 minus x squared all over y squared. So this is the first partial derivative of z with respect to x. With respect to x. Right. Let's continue and find the second partial derivative with respect to y. We just found the first with respect to x. Let's differentiate this again with respect to y, okay? So for us to do that, we are going to apply the quotient rule. You remember quotient rule, okay? We say v du minus u dv all over v squared. That is what we are going to apply here. So the numerator is our u, the denominator is our v, okay? So the second partial derivative with respect to y, we are having partial derivative with respect to y of this partial derivative of z with respect to x, okay? So it's going to give us here from our formula where we say v du, that means the v, which is the denominator, we're going to bring it up. So when you bring it up, multiply by the derivative of u. So when you differentiate u, which is 1, with respect to y, it's going to give you 0. So we have multiplied by 0. Then minus the u, which is 1, multiplied by the derivative of the denominator, which is v. Okay, all over v squared. So v squared we have is y, open bracket, square root of 1 minus x squared all over y squared, all in bracket squared. Right? Now look at this. This v, the derivative of v, let's differentiate it. So let's carry the whole v. Let's carry it and call it a letter here, k. Let's say that k is equal to y, open bracket, square root of 1 minus x squared all over y squared. So this is what we want to differentiate, okay? So we want to find the derivative of this k with respect to y. Then we bring it up here, okay? We bring it up. Now, how are we going to do this? Now, look at this carefully. You see that we have y, square root of 1 minus x squared all over y squared. We are going to apply product rule. We are going to apply product rule. How? We are going to differentiate y multiplied by the square root of 1 minus x squared all over y squared plus differentiate square root of 1 minus x squared all over y squared times y. Are we together? That is the product rule. Look at it. U dv plus v du. Okay, now let's go. When we differentiate y with respect to y, it's going to give us 1. Then multiply by square root of 1 minus x squared all over y squared plus We have y multiplied by, when we differentiate square root of 1 minus x squared all over y squared, let's differentiate that. So differentiating square root of 1 minus x squared all over y squared, we are going to say let a equal to the square root, right? Now, and it's the same thing as saying 1 minus x squared all over y squared all in bracket raised to power 1 all over 2. It's still the same thing, right? Good. Now let's differentiate this a with respect to y. That is what we're looking for, right? So differentiating this a with respect to y, we are going to apply chain rule. So we said this content inside this bracket, let's call it a letter p. Then we say p is equal to 1 minus x squared all over y squared. Differentiate this p with respect to y. So when we differentiate this, we have the p all over the y is equal to minus, open bracket, minus 2x squared all over y cube. Do you understand? Yes. So when we differentiate p with respect to y, so this is what we're going to get. Now, remember, we are trying to differentiate a. So we say that a is equal to 1 minus x squared all over y squared in bracket 1 all over 2. And we called the content of this bracket a letter p. So that means we have a is equal to p raised to the power of 1 all over 2. Are we together? Yes. Now let's differentiate this a with respect to p. Differentiating a with respect to p partially, we are going to have partial a all over partial p is equal to 1 all over 2 multiplied by p raised to the power of minus 1 all over 2. So when we simplify this, we're going to have 1 all over 2 multiplied by 1 all over p raised to the power of 1 all over 2. This raised to the power of 1 all over 2 is the same thing as saying root. So here we have that the partial a all over the partial p is equal to 1 all over 2 root p. Are we together? Yes. The partial a all over partial p is equal to 1 all over 2 root p. Now, remember that we are trying to differentiate a, right? And we say that a is 1 minus x squared all over y squared in bracket raised to the power of 1 all over 2. And we try using chain rule. Okay? So, chain rule that we have, we said 1 minus x squared all over y squared is to be called a letter p. And we differentiated the p with respect to y, right? And then we differentiated a, that is having p raised to the power of 1 all over 2. So we multiply these two derivatives to get the partial a all over partial y. Okay, so this is the formula. We said that the partial a all over partial y is equal to these two derivatives that we just obtained now, which is the partial a all over partial p multiplied by partial p all over partial y. Are we together? So when we bring them together, we say that partial a all over partial y is equal to 1 all over 2 root p multiplied by 2x squared all over y cubed, right? So when we combine these together, but bear in mind that p is 1 all over 1. Bear in mind that p is 1 minus x squared all over y squared, right? Good. Let's bring it here in place of p and then multiply both of them together. So when we bring it together, we have that partial a all over partial y is equal to 2x squared all over 2y cubed square root of 1 minus x squared all over y squared. Are we together? Yes. Now look at it. In our numerator, we have 2. In our denominator, we also have 2. So they can cancel each other. So we are going to have that the partial a all over partial y is equal to x squared all over y cubed square root of 1 minus x squared all over y squared. Are we together? Yes. Now look at it. Remember that we are trying to solve k, right? We are trying to solve k, and we say let's use product rule to solve k. Look at it, we are solving it. So we just found the derivative of the square root of 1 minus x squared all over y squared with respect to y. That is what we found. So we bring it back here in the derivative of k with respect to y, the partial derivative of k with respect to y. So bringing it here now, we have that the partial k all over partial y is equal to 1 multiplied by square root of 1 minus x squared all over y squared plus y multiplied by x squared all over y cubed multiplied by square root of 1 minus x squared all over y squared. Okay, so we just substituted. Okay, in this partial derivative of k with respect to y. We substituted. So this is what we have. All right, good. Now let's simplify this. Let's simplify. So here we have 1 multiplied by is still the same square root of 1 minus x squared all over y squared plus. Now here we have y multiplied by x squared all over y cubed square root of 1 minus x squared all over y squared. Let's multiply. So the y is going to go up. We are going to have x squared multiplied by y all over y cubed square root of 1 minus x squared y squared. So since we have y in the numerator and there is also y cube in the denominator, so one of those y we cancel. Okay, so when they cancel, we are going to have x squared all over y squared square root of 1 minus x squared all over y squared. Okay, so the partial k all over partial y is equal to square root of 1 minus x squared all over y squared all over 1, which is the same, right? Plus x squared all over y squared square root of 1 minus x squared all over y squared. Are we together? Yes. Now look at this. Let's combine these two together, please. Let's combine the two together. So combining the two together, we're going to look for the LCM. Okay, we're going to look for the LCM. So looking for the LCM is what? Is y squared square root of 1 minus x squared all over y squared. So when you say y squared square root of 1 minus x squared all over y squared divided by 1, that is the denominator here, right? In this first part, is going to give you the same thing. So this same thing multiplied by the numerator, which is square root of 1 minus x squared all over y squared. When we multiply by the numerator, we're going to have y squared, open bracket, 1 minus x squared all over y squared. How do you do this? Now remember the law of indices. When you have a raised to the power of m multiplied by a raised to the power of n, what do? You add their powers together. So the square root of 1 minus x squared all over y squared multiplied by the square root of 1 minus x squared all over y squared is root, right? Which is 1 all over 2. So when you add 1 all over 2 together, it's going to give you 1. So the root is going to cancel. Then we have 1 minus x squared all over y squared remaining, right? Yes, then plus the second side. When you say y squared multiplied by 1 minus x squared all over y squared, when they divide each other, right, it's going to give you 1. So 1 multiplied by the numerator is going to give you x squared. That is 1 multiplied by x squared. All right. So when we combine these two together, we have that the partial k all over partial y is equal to y squared, open bracket, 1 minus x squared all over y squared plus x squared all over y squared square root of 1 minus x squared all over y squared. Are we together? Yes. Now in the numerator, let's open the bracket. When you say y squared multiplied by 1 is going to give you y squared. And when you say y squared multiplied by x squared all over y squared, so the y squared is going to cancel the y squared. So we are going to have x squared remaining. So therefore, we are going to have y squared minus x squared plus x squared all over. In the denominator, we have y squared, open bracket, square root of 1 minus x squared all over y squared, right? Now look at the numerator. We have minus x squared plus x squared, which is going to give us what? 0. When you say minus x squared plus x squared, 0. We are going to have y squared remaining in the numerator. Now, we have y squared in the numerator and we have y squared in the denominator. So they are going to cancel each other. Then we have 1 in the numerator all over square root of 1 minus x squared all over y squared. Are we together? Yes. Now, look at it. When we started the second partial derivative with respect to y, you remember we are using quotient rule, and then the quotient rule said v du minus u dv all over v squared. Now we brought the v up, multiplied by the derivative of u, which is 0, then minus the u, which is 1, multiply by the derivative of v. Now, the derivative of v is what we just solved now. Okay, so the derivative of v that we solved, we bring it up here, then all over v squared, which is the denominator, y open bracket square root of 1 minus x squared all over y squared, all a bracket squared. Okay, so bringing it back now, we have that the partial derivative with respect to y of partial z all over partial x is equal to y open bracket square root of 1 minus x squared all over y squared multiplied by 0 minus 1 multiplied by 1 all over square root of 1 minus x squared all over y squared all over the denominator, which is v squared, y open bracket square root of 1 minus x squared all over y squared, all in bracket squared. Hello, are we together? Yes, now let's go. Now, in the numerator where we have multiplied by 0, everything in the first part is going to be 0. Then we have minus 1 multiplied by 1 all over square root of 1 minus x squared all over y squared is going to give us minus 1 all over square root of 1 minus x squared all over y squared. Then in the denominator, what do we do? Now, look at it. We are going to have divided by. This denominator is the same thing as saying divided by square root of y. Is the same thing as saying divided by, we have y square root of 1 minus x squared all over y squared, all the bracket squared, right? Good. Now look at this. In this divided by, which is the denominator, let's open the bracket by distributing the squared to the content of this bracket. So when you open it, you are going to have y squared, then this square root inside will be cancelled by the squared outside when you open the bracket. Okay, so that means we have the second partial derivative of z with respect to y with respect to x is equal to minus 1 all over square root of 1 minus x squared all over y squared divided by y squared open bracket 1 minus x squared all over y squared. Are we together? Yes. Now this second part where we have y squared open bracket 1 minus x squared all over y squared, let's multiply. Let's use y squared to open the bracket. So when you use y squared to open the bracket, we have y squared multiplied by 1. It's going to give you y squared. Then y squared multiplied by x squared all over y squared. So the y squared is going to cancel. So we are going to have x squared remaining. So therefore, here we have the second partial derivative of z with respect to y with respect to x is equal to minus 1 all over square root of 1 minus x squared all over y squared divided by y squared minus x squared all over 1. So divided by, we change this division to multiplication and we invert. The numerator will come down to denominator and the denominator will go up to numerator. Let's do that. So here we're going to have that the first and second partial derivative of z with respect to y with respect to x is equal to minus 1 all over square root of 1 minus x squared all over y squared multiplied by the inversion. Now the denominator is 1, it will come up to numerator all over the numerator will come down to denominator, which is y squared minus x squared. Okay, so let's write it properly. So we see that the first and the second partial derivative with respect to y and with respect to x. Okay, the first and the second partial derivative of z with respect to x with respect to y is equal to, we have minus 1 all over y squared minus x squared in bracket square root of 1 minus x squared all over y squared. Yes, this is the first part. Yes, and I hope this is very clear, right? Good. Now let's take the second part of it. The second part, we are going to find the first derivative with respect to y, then the second derivative with respect to x. Now let's do this. In this case, we are going to rush everything because by now you have known what we are doing, right? Now let's go. We simply say let u equal to x all over y, right? Good. And then we differentiate u with respect to y. We are starting with y. So we differentiate with respect to y partially. So when we differentiate with respect to y partially, we are going to have minus x all over y squared. Are we together? Yes. Now you know that your z is sine inverse of x all over y, and we just did a substitution u. So that means we have z is equal to sine inverse of u. All right. Yes. So now, since we have z is equal to sine inverse of u, we differentiate this z with respect to u, right? Partially with respect to u, because the z now is now a function of u. So differentiating, you are going to have the partial z all over partial u is equal to 1 all over square root of 1 minus u squared. Are we together? Yes. Now, bringing these two derivatives that we have, we say that the partial z all over partial y that we are looking for is the product of these two derivatives, which are the partial derivative of z with respect to u multiplied by the partial derivative of u with respect to y. So let's bring them together. We have that the partial z all over partial y is equal to 1 all over square root of 1 minus u squared multiplied by minus x all over y squared. All right? Yes. Now, pay attention. You know that u is equal to x all over y, right? Let's bring it here. Let's substitute. We are going to have that the partial z all over partial y is equal to minus x all over y squared square root of 1 minus x all over y. That is in place of u now, right? X all over y squared. Let's open this x all over y squared. Let's use the square to open the bracket. So when you open the bracket, we are going to see that the partial z all over partial y is equal to minus x all over y squared, open bracket, square root of 1 minus x squared all over y squared. So this is the first derivative, partial derivative of z with respect to y. Now let's go again and find the second partial derivative of this same z with respect to x. Okay, so we apply quotient rule as usual, and then you know that your quotient rule is v du minus u dv all over v square, right? Good. Now look at it. We are saying the partial derivative with respect to x of the partial derivative of z with respect to y. Okay, now this partial derivative of z with respect to y that we just obtained, let's find the partial derivative with respect to x. Okay, now let's go. So applying the quotient rule, remember you have minus, so we have minus. So we bring the v up, right? So when you bring the v is y squared open bracket square root of 1 minus x squared all over y squared, right? Multiply by du. You differentiate u, which is numerator. So when you differentiate u, which is numerator, x, right, is going to give you 1. So here we're going to have 1. Then minus, we have u dv. Your u, which is x, right, multiply by dv all over your v squared, okay, which is y squared open bracket square root of 1 minus x squared all over y squared all in bracket squared. Now this dv, now v is your denominator. Let's pick it and differentiate it with respect to x, and then we bring it up here. So for us to differentiate, let's call it a letter k. Let's assume that is a function on its own, right? We say k is equal to y squared open bracket square root of 1 minus x squared all over y squared. This is the denominator. We want to differentiate this denominator and bring it up, right? So we differentiate it with respect to x. So here we're going to apply product rule. We differentiate y squared multiply by square root of 1 minus x squared all over y squared plus differentiate square root of 1 minus x squared all over y squared multiply by y squared. Are we together? Yes. Now let's do that. We say the partial k all over partial x is equal to, when you differentiate y squared with respect to x, it's going to give you 0. Then multiply by square root of 1 minus x squared all over y squared. Then plus the y squared times, when you differentiate square root of 1 minus x squared all over y squared with respect to x. Okay, now let's do that. For us to do that, let's say that this square root of 1 minus x squared all over y squared is a. We say a is equal to this, right? And we can write it and say that a is equal to 1 minus x squared all over y squared in bracket raised to the power of 1 all over 2. Okay, it's still the same, right? Now, for us to differentiate this guy, we apply chain rule. Chain rule, we said let p equal to 1 minus x squared all over y squared. We differentiate this p with respect to x. Hello. We differentiate this p with what? With respect to x. So differentiating this p with respect to x, we are going to have minus 2x all over y squared. We are going to have minus 2x all over y squared. Now, let's go. Here we have a. A is equal to 1 minus x squared all over y squared, a bracket 1 all over 2, raised to the power of 1 all over 2, right? And we said that p is equal to 1 minus x squared all over y squared. That means a is now p raised to the power of 1 all over 2. We differentiate a with respect to p partially. So when we do that, we are going to see that the partial a all over partial p is equal to 1 all over p is equal to 1 all over 2 multiplied by p raised to the power of minus 1 all over 2, okay? Which is the same as saying 1 all over 2 times 1 all over p raised to the power of 1 all over 2. Then p raised to the power of 1 all over 2 is the same thing as saying root p. So here we have that the partial a all over partial p is equal to 1 all over 2 root p. Okay? Now remember, we are trying to find the partial derivative of a with respect to x. Okay? And we are trying to use chain rule. So chain rule say that the partial a all over partial x that we are looking for is the product of these two derivatives that you just obtained, which is the partial a all over partial x is equal to partial a all over partial p multiplied by partial p all over partial x. We know them. Let's bring them together. Now we see that partial a all over partial x is equal to partial a all over partial p is what? 1 all over 2 root p times partial p all over partial x is minus 2x all over y squared. Remember that p is 1 minus x squared all over y squared. Let's bring it here now. So bringing it here, we have that the partial a all over partial x is equal to minus 2x all over 2 y squared square root of 1 minus x squared all over y squared. Hello, we just bring it together, substitute and multiply, right? Good. Now look at the numerator, we have 2. The denominator, we also have 2. So this 2 is going to cancel, right? So after the cancellation, we are going to have that the partial a all over partial x is equal to minus x all over y squared square root of 1 minus x squared all over y squared. Are we together? Yes. Now let's go. You remember that we are trying to solve the partial k all over partial x, right? And when we started, we said we are applying product rule. So we differentiated y squared multiplied by square root of 1 minus x squared all over y squared plus y squared multiplied by the derivative of square root of 1 minus x squared all over y squared, right? Good. And when we differentiated y squared, it gave us 0. That is with respect to x. Then multiply by square root of 1 minus x squared all over y squared. Then plus y squared multiplied by, when we differentiate square root of 1 minus x squared all over y squared with respect to x. Okay? So that is what we just obtained now. We substitute it here. When you substitute, we have minus, that is multiplied by minus x all over y squared square root of 1 minus x squared all over y squared. So let's simplify. So here we have 0 multiplied by square root of this is equal to 0. Then in the other side we have y squared multiplied by minus x all over y squared square root of 1 minus x squared all over y squared. So when you multiply this, you are going to have that the partial k all over partial x is equal to minus x y squared all over y squared square root of 1 minus x squared all over y squared, right? Yes. Now look at this. In the numerator, you have y squared. In the denominator, you also have y squared. So let's cancel out the y squared. So after the cancellation, we are going to see that the partial k all over partial x is equal to minus x all over square root of 1 minus x squared all over y squared. Are we together? Yes. Now let's go. Remember that the second partial derivative that we're looking for with respect to x of the partial z all over partial y, we apply quotient rule. And quotient rule say v du minus u dv all over v squared. And we brought v up, right? Differentiated u, which is 1. Then we say minus, we have x multiplied by dv. So dv is this partial k all over partial x that we just solved now. So as we found the partial k all over partial x, which is the dv that we're looking for, the derivative of the v, the derivative of the denominator. So here we brought it up here. So when we bring it up here, we have that the partial derivative with respect to x of partial z all over partial y is equal to, we have minus 1, or we have minus, here we have y squared square root of 1 minus x squared all over y squared multiplied by 1, then minus, we have x multiplied by the dv that we just obtained, which is minus x all over square root of 1 minus x squared all over y squared all over v squared. V squared is what? Is y squared, open bracket, square root of 1 minus x squared all over y squared, all in bracket squared. Are we together? Yes. Now, let's work on the numerator. Okay, so working on the numerator, we have that the partial z all over the second partial derivative of z with respect to x with respect to y is equal to minus, in the numerator we have y squared, open bracket, square root of 1 minus x squared all over y squared all over 1. Okay, you can decide to write say all over 1. Then we have plus. Here we have minus x multiplied by minus x. It's going to give us positive x squared. Then all over square root of 1 minus x squared all over y squared. Then in a denominator, let's open the bracket, the squared, okay, the power squared. Let's use it to open the bracket. So when you open the bracket, we're going to have y raised to the power of 4, open bracket, 1 minus x squared all over y squared. So when you use this raised to the power of 2 to open the bracket, where you have square root, is going to cancel the square root, okay? So here we have y raised to the power of 4, open bracket, 1 minus x squared all over y squared, all right, as the denominator. Now let's go. In this numerator, let's combine the numerator together, okay? Let's combine the numerator. So combining the numerator, we are going to look for the LCM. So the LCM is simply square root of 1 minus x squared all over y squared, okay? So when you say square root of 1 minus x squared all over y squared divided by 1, it's going to give you 1. Then multiply by the numerator. The numerator is y squared, open bracket, square root of 1 minus x squared all over y squared, okay? So when you multiply it, we're going to have y squared, open bracket, 1 minus x squared all over y squared. And I have explained how we got this, right? Yes, then we say plus. Now, when you use this LCM now, which is square root of 1 minus x squared all over y squared, divided by the same square root of 1 minus x squared all over y squared, is going to give you 1. Then multiply by the numerator, which is x, it's going to give you plus x squared, right? The numerator is x squared, okay? So it's going to give you plus x squared. Now, instead of saying all over again, we say divided by. We say divided by, okay? It's still the same. By y raised to the power of 4, open bracket, 1 minus x squared all over y squared, right? Yes. Now let's go. So now look at this. From this place where we have the partial derivative, the second partial derivative of z with respect to x with respect to y. Here we have minus y squared, open bracket, 1 minus x squared all over y squared, bracket, plus x squared all over square root of 1 minus x squared all over y squared, divided by y raised to the power of 4, open bracket, 1 minus x squared all over y squared, all over 1, okay? So in this case now, let's open the bracket, or let's simplify the numerator in this first part. To simplify the numerator, you first of all use y squared to open the bracket. So using y squared to open the bracket, you see y squared multiplied by 1 is going to give you y squared. Then y squared multiplied by x squared all over y squared. So y squared is going to cancel y squared. So we're going to have x squared remaining. So here in the numerator, you have y squared minus x squared plus x squared all over square root of 1 minus x squared all over y squared. Then in this place we have divided by. So we're going to change the division to multiplication and then perform inversion. Okay, so that means we're going to have multiply by. So here we have y raised to the power of 4, open bracket, 1 minus x squared all over y squared. So we're going to use this y raised to the power of 4 to open the bracket. So when you open the bracket, we're going to have y squared y raised to the power of 4 multiplied by 1 is y raised to the power of 4. Then y raised to the power of 4 multiplied by x squared all over y squared. Y squared is going to cancel. Then you have another y squared remaining. Okay, so here we're going to have y raised to the power of 4 minus x squared y squared. Okay, good. So here in this first part where you have y squared minus x squared plus x squared, so when you have minus x squared plus x squared, it's going to give you 0. Then you are going to have y squared remaining. So the first part we have minus y squared all over square root of 1 minus x squared all over y squared multiplied by 1 all over. In this y raised to the power of 4 minus x squared multiplied by y squared, let's factor out y squared. So when you factor out y squared, you're going to have y squared minus x squared. So remember, you have y squared in the numerator. So y squared in the numerator multiply or divided by y squared in the denominator. Okay, they are going to cancel each other. So therefore, we are going to have that the second partial derivative of z with respect to x with respect to y is equal to minus 1 all over y squared minus x squared in bracket square root of 1 minus x squared all over y squared. Okay, so here we solved. We found the first partial derivative with respect to x and then again with respect to y. We kept the answer and then we come back again, find the first partial derivative with respect to y, then with respect to x. At the end of the day, we discover that the first and the second partial derivative of z with respect to x and with respect to y and with respect to y and with respect to x is the same, which is equal to 1 all over y squared minus x squared in bracket multiplied by square root of 1 minus x squared all over y squared. All right, yes, this is the simple way to solve this, though it's long, but once you are familiar with the steps to know exactly what to do at any time, I don't think it's going to give you an issue. Okay, so I want you to practice this and solve this by yourself. Keep practicing, keep learning. All right, thank you very much for watching our video. Please, if you are new to our YouTube channel, do well to like, subscribe and share our videos. Stay blessed. Thank you.